ChatGPT and other large language models have reshaped how we learn, work, and even think, bringing artificial intelligence into the daily lives of millions across the world. What makes this different from past technologies is its accessibility. Anyone, anywhere, can now generate complex text at speeds we've never seen before. This shift hasn't just changed our routines, it set civilization on a new path. In this video, I want to clear up some of the mystery around how ChatGPT actually works, so you can understand what's happening every time you start a conversation, and why it feels so powerful. Hi, my name is Oliver, and I am a computer science student who is passionate about artificial intelligence. I've had a deep interest in AI since I was a child, and had taken it up as a focus in my studies for that reason. The application is highly interesting, and knowledge about AI has become increasingly valuable since the widespread use of technologies like ChatGPT. To help educate about this technology, and maybe get you interested in the technical aspects, I have created this video. So to start off, I want to decompose these concepts at first. So we have ChatGPT, which specifically in technical terms is a large language model, or LLM. So ChatGPT is just one instance of this technology. You might have heard of Gemini, Llama, Claude, and countless other large language models. These all work very similar ways, based on the same technology. The name ChatGPT is composed of the word chat and GPT. You might be familiar of specific models like GPT-3 or GPT-4o if you've used it before. So you can see that this GPT is used in several places. So GPT actually means generative pre-trained transformer. I will get into the specific definitions of these words later on, but let's look at the first one, the generative. So if you've used ChatGPT, you see that it actually generates something. That's why it's called generative. I've opened ChatGPT here to show you this generative effect. So the way it works is I enter some sentence, so some string of words, and then I can execute this language model to produce an output, so to generate an output for us. Here I've asked it to make up a haiku, and we'll see that it responds by generating something. You saw that it appeared bit by bit, and it generates this output, so to say, word by word. I also briefly want to note that large language models work over something called tokens. These are very similar to words, but might be different. They just help a computer decompose language in a way that's understandable for it. Here, for example, you can see how the model we just used, GPT-4o, decomposes these sentences. So you can see there's some words that get mapped one-to-one to a token, which is color-coded here, and some words are composed of several tokens. You can see also here with numbers, it's the same thing. And the way they're represented in computers is through IDs. So this is what the sentence or these sentences actually look like in the computer. They're just a string of these tokens. And this is then what gets fed into a large language model. So let's get back to the term large language model, specifically language model. What a language model is in this context is some probabilistic distribution. So some probabilities that tell us how likely one word is to follow another. I will show this by an example. If we have the string of words, the weather today is, this can be processed to then define which words could be potential next words. In our example, the next possible words might be sunny, cloudy, or rainy. And our language model then tells us what the probability of these words is. So with 40% probability, the next word might be sunny, and with 25%, for example, rainy. And this is already essentially all that a language model does. It tells you, based on a string of words, what is the next word that might appear, or what are the probabilities of these words. And just to note, every time I say words, I technically mean tokens, but you can think of them as the same thing, as it's simpler to visualize it that way. It's also relevant to know that a language model tells us what the probabilities are, but then when we generate something, like we've seen with the example of ChatGPT, we need to choose which word comes next. And this often is done by choosing the word that's the most likely to be next. This is most often done. However, there are also arguments for taking less probable words at times to make a response seem more creative or unique. Now, language models is the generic term for this probability distribution, so the percentages for what word is most likely to follow. And large language models are much more powerful, and I'll explain why they are like that a bit later. And this is, for example, what ChatGPT is. Now, how exactly do they work? Well, you can realize this distribution of probabilities in several different ways, but ChatGPT and other large language models, which have become famous over the last years, all rely on something called a transformer. A transformer you might recognize from this term that we decomposed, the GPT. So we know what generative means, and now transformer is what we look at next. Now I just wanted to show this real quick. This is a transformer, but it is not important right now how exactly this works. I'll just explain what it does. But the basis of these transformers, are actually neural networks. And I've made a video on these before, and I suggest you watch it, because they are highly interesting and very powerful, used almost in all of the most powerful AI models used today. Now, what a transformer does is it reads this sentence from left to right, so starting from the first word and then moving on, and then each step of the way, it updates its internal state. So it stores information about what word it just read, and then also information such as how words are related. Now, the specifics are a lot more complicated, but all you need to know is that it decides what the next word choice is based on all the words that are before it. And these transformers have proven to be very efficient in processing long text and learn deep patterns, like how one word might associate to another, and how, for example, adjectives affect the information of nouns. So if we would have the sentence, the green car, a transformer would be able to take the meaning of green and insert it into the meaning of car. And this is what makes them so powerful. But then why do these work? Why does a large language model know that a certain word has a certain probability? Well, for this, a model is actually trained, so it learns from data, similar to how humans learn in school, for example. And this is also where we get the second term of GPT, pre-trained. So we have training in the word here, and the word pre-training refers to a method where large amounts of data, so for example, blog posts from the internet, or PDFs, or descriptions of YouTube videos, something like that. And using this large amount of data, general knowledge about language can be learned. So, for example, it can be learned that when we have the sentence, the weather today, then we know what is likely to follow. That is could be another word, or will be. So pre-training usually just learns the general language knowledge. So grammar, something like this. Then you can learn specific behavior in a method called fine-tuning. Here, more specific data sets are used, but I will not get into this anymore because actually, ChatGPT does not rely on fine-tuning. It does do another type of learning, namely learning from humans, or rather from human feedback, but that is not further important for this video. But what you can see now is that ChatGPT actually learns, so is trained on data. And this data, as I mentioned, comes from the internet. So it's what other people wrote. And it's not curated, so if there's some false information on the internet, the training data isn't first cleaned of it. Or rather, it is attempted to do this, but because of so much information that is on the internet, that is just not possible. So in the end, there are human errors, there are false things in the learning data. And for this reason, large language models sometimes make errors. And you should not always believe everything that a large language model says, as it could just give you the most likely next word. So perhaps tomorrow it will rain, But because the large language model knows that it's more likely that it will be sunny, it will tell you it is sunny. And that is a very big issue with large language models, especially in widespread use. So I really suggest that when you use large language models, that you are careful and don't believe everything it says. Again, if you are interested in this and want to learn more, specifically about neural networks, I suggest you watch my video on that. This is not just relevant for large language models, but most of what is being done with artificial intelligence nowadays. I hope you enjoyed this video. Please let me know in the comments if there's any topic which you would like me to make a video on in the future. And like and subscribe to be notified about new videos of mine. Thanks for watching.